Welcome to the Nordic Venture Show, your speed date with the coolest ventures, brightest founders, and exciting things happening in the Nordics. In this episode, our venture date is with NitroVolt, Decentralized Sustainable Ammonia Synthesis.
Welcome to the Deep Dive. Today we're looking into NitroVolt. They're a company trying to, really shake up how we produce something absolutely essential. Ammonia.
That's right, ammonia. Maybe not top of mind every day, but it's fundamental, about 80% of it. That goes into fertilizer. It's how we grow enough food, basically.
Exactly. But here's the thing. The way we make nearly all of it now, this Haber-Bosch process, it's old, early 20th century old. And while it was amazing for its time, it uses a ton of energy.
Oh, absolutely. Think really high heat. We're talking 400, 500 degrees Celsius and intense pressure. Plus, the hydrogen it needs comes mostly from natural gas, fossil fuels.
And that adds up, doesn't it? The whole process is responsible for something like, 1.3 to 1.5% of global greenhouse gas emissions.
That's the figure, yeah.
Right.
It's significant. So the very thing helping feed the world is also a major climate contributor.
And these plants are usually huge centralized places, right?
Yeah.
So you get transport emissions on top of that. It's
Yeah.
quite a problem.
A huge problem. And that's exactly where NitroVolt enters the story. They spun out of research at the Technical University of Denmark, starting back in 2017.
Okay.
And they're suggesting a totally different way. It's not just talk either. They've got papers in big journals, Nature, Science, serious scientific backing.
So NitroVolt is moving away from that old heat and pressure approach. What's their solution then? What's the core idea?
Their main tech is called the Nitrolyzer. It uses a new patent-pending process based on lithium chemistry to make ammonia.
Lithium. Okay, interesting. So instead of brute force energy, it's a different chemical route.
Exactly. A smarter pathway, you could say.
And what goes into this Nitrolyzer? What are the ingredients?
Well, this is where it gets really compelling. It uses air, water, and green electricity.
Green electricity. Okay, that's key.
Absolutely crucial, because using renewables means they can produce green ammonia that's totally different from the usual gray ammonia made with fossil fuels.
Air, water, renewables. That feels fundamentally different. What about the units themselves? Are they big plants too?
No, that's another big difference. They're designed as modular, container-sized units. Think shipping containers.
Container-sized? Really?
Yep, and the idea is you can put them right where you need the ammonia, directly on a farm, maybe a greenhouse or another industrial site.
Wow, okay, so on-demand production.
Exactly. It cuts out all that long-distance transport and the emissions that go with it. It's about decentralizing production.
That seems like a massive shift. No more shipping fertilizer across countries or continents.
Sure.
Addresses emissions, supply chain risks, all of that.
Precisely. And you asked about scale. They're designed to be scalable.
How scalable?
They can be configured to produce anywhere from, say, a few hundred kilograms up to thousands of kilograms of ammonia per day. So it could work for different sizes of operations.
That flexibility is important. But the idea of farmers, actually controlling their own fertilizer production on site, that feels potentially revolutionary.
It really could be. Think about resilience, independence from volatile global fertilizer prices, or supply chain snags. It gives farmers a lot more control over a critical input.
Yeah, huge potential there for resilience in agriculture. Okay, so we get the what's green ammonia, made locally. Let's dig into the how a bit. What's the basic science inside that Nitrolyzer?
Sure. It's a neat cycle, actually. First, they use electricity, that ammonia electricity, to reduce a lithium salt down to reactive metallic lithium.
Okay.
Then this metallic lithium grabs nitrogen right out of the air. Air is mostly nitrogen, after all. It forms something called lithium nitride.
Got it. Lithium grabs the nitrogen. Then what?
Then they introduce hydrogen. This hydrogen comes from splitting water, again using that green electricity. The hydrogen reacts with the lithium nitride.
And that makes ammonia.
That makes ammonia, yes. The hydrogen essentially kicks the lithium out and combines with the nitrogen and the lithium. It gets regenerated, ready to start the cycle all over again.
So the lithium isn't consumed, it just helps the reaction along, like a catalyst or an intermediary.
Kind of like an intermediary, yeah. It shuttles the nitrogen through the process. And this all happens continuously in their special flow cell reactor design. That's part of their patent.
A continuous flow.
Right.
Okay, let's circle back to the environmental side. We said green ammonia, zero emissions. Can we quantify that impact?
Well, NitroVolt's target is pretty clear. 0 kilograms of CO2 emitted per kilogram of ammonia produced, Compare that to the, significant emissions from Haber-Bosch.
0 at production. That's huge.
And then, as we said, because it's produced on site, you also aim to eliminate all the emissions from transportation and logistics.
That really tackles the problem from both ends, production and distribution.
Definitely. And NitroVolt points out this aligns directly with some key UN Sustainable Development Goals.
Which ones?
Specifically, Goal 2 is zero hunger, because fertilizer is key for food security. Goal 12, responsible production and consumption. And Goal 13, climate action, for obvious reasons.
So it ties into those bigger global pushes for sustainability. Okay, this sounds great in theory. Where is NitroVolt as a company? What progress have they made?
They seem to be moving steadily. Their newsletters mention closing a $3.5 million seed funding round late last year, November 2024.
Okay, seed funding is a good sign. Shows investor confidence.
Absolutely. And before that, last fall, they started their first actual experiments in their own labs, the Nitro Labs.
So moving from university research to their own setup.
Right. The labs became operational around August 2024, and they moved into new facilities at the Alpha Laval Innovation House back in July. So you see a clear progression: funding, labs, initial experiments.
Building momentum. And this is all built on that solid academic foundation.
Yes, 7 years of research at the Technical University of Denmark. Like we said, backed by publications in really high-impact journals. It's not just an idea sketched on a napkin.
Good point. What about the team? Who's behind this?
They describe themselves as visionaries, scientists, makers, and doers. Importantly, the CEO and the CTO are actually the researchers who pioneered the specific lithium process back at the university.
Ah, so the inventors are running the show. That's often a good sign. They really understand the core tech.
You'd think so, yes. Deep expertise right at the top.
Okay, let's tackle some common questions someone listening might have. Our sources touched on a few FAQs, like just the basics. What is ammonia again, chemically?
Simple molecule, 1 nitrogen atom, 3 hydrogen atoms, NH3. And yeah, it's one of the most produced chemicals on the planet.
And we know 80% is fertilizer, but what else is it used for?
Quite a range, actually. It's used as a refrigerant gas for purifying water, making plastics, even explosives, textiles, dyes, pesticides. Lots of other chemical processes use it as a building block.
So versatile stuff, and we keep saying gray versus green ammonia, just to nail that down.
Right. Gray is the standard today, uses natural gas or other fossil fuels, lots of CO2 emissions. Green ammonia, like NitroVolt aims for, uses renewable electricity, water, and air. The goal is 0 CO2 in production.
And NitroVolt is firmly in the green camp. Air, water, renewable power, no CO2 during production.
Got it. That's their whole premise. And while farming is a huge focus, they do say the tech could work for any site needing roughly 150 to 1,000 kilos of ammonia per day.
So potential beyond agriculture, too. Maybe industrial uses on a smaller scale.
Could be, yeah. Anywhere that needs that amount on site could potentially benefit.
And finally, intellectual property. Is this tech protected?
Yes. They mentioned 3 pending patents covering the whole system, the inputs, how it operates, the flow cell design, the specific catalysts involved. They're locking down their innovation.
Okay, good to know. So wrapping this up, what's the big picture here, the main takeaway from our deep dive on NitroVolt?
I think the key thing is that NitroVolt offers a really promising, potentially game-changing path towards sustainable ammonia. It's decentralized, cuts out massive CO2 emissions from the traditional method, and could empower end users, especially farmers.
Yeah, moving away from huge polluting central plants to smaller, cleaner on-site units. And the core innovation is that Nitrolyzer tech using just air, water, and green power via that lithium process.
Exactly. It's a fundamental rethink of an old, established, but problematic industrial process.
It really makes you wonder, doesn't it? As we push harder for sustainable solutions and smaller carbon footprints, what other big industrial processes are out there just waiting for a similar kind of decentralized green overhaul?
That's a fascinating question, this idea of localized, on-demand, green production.
Yeah.
It feels like it could apply in many other areas beyond just ammonia.
Definitely something to think about. If you want to dig deeper into NitroVolt, you can check out their website or their LinkedIn page. Thanks for joining us for this deep dive.
Thanks for tuning in. You can follow us on Spotify, Apple Podcasts, Google Music, or your favorite app, and connect with us on LinkedIn for more stories and insights.